For our next operation, we're going to run 2.5-inch hole saw. Refer to your cutting tools manufacturer for the feeds and speeds for these kinds of tools. We're going to run around 800. And just take it nice and easy. You don't want to melt your plastic. So you notice I'm clearing the chips and I'm not dwelling, because if you dwell, that's when you can begin to weld the chips that you're creating around the periphery of the cutter, and things can jam up and get nasty. And again, we don't want to pound this right out the other side, because that point where it breaks through can be a little dicey. And there you go. We're through. Nice clean cut. And I'm not going to touch that right now. We're going to pause. And we're going to come back in a minute, and we'll show you what the piece that we cut out of there looks like. So we just hole sawed with this 2.5-inch hole saw through about 0.8-inch thick block of PVC. Now some of you might wonder, what if we have a thicker block? You know, what if our block is closer to 2 inches thick? So in that case, there's a couple things to consider. Your hole saw actually creates a plug that needs to be removed. They're designed for cutting through sheet material. So your limitation is measured essentially from the face of the teeth to the beginning of this radius that's formed right here. So for this specific saw, we could safely say that we can go about 0.95 inches deep before we're going to run into trouble. So if our block is over 2 times 0.95, we're going to run into trouble. So as you can see here, we're just not quite going to make it. So if you don't have the option to make your block thinner by milling it down or saw cutting it, you do have the option to hole saw, change this out for an end mill, cut some of that material out, and then hole saw the rest of it. Now that's a band-aid solution. You really don't want to do that unless you have no other option. But in this case, we can cut this down thinner. So I'm going to pop a face mill in, and I'm going to cut this down to a nice, safer thickness for our job. And I'm going to hole saw from both sides. So we're going to hole saw this way, and we're going to flip it, and we're going to have a pilot hole that we're going to then meet up with this drill, and we'll complete it from this side. Next question is, what size is the pilot drill inside a hole saw? Because the first thing we're going to want to do is drill that hole. It's 1/4 inch. And we're going to run this drill around 1,000 RPM. This ABS cuts quite nice. As you can see, the chips are coming off pretty clean. So once again, we don't want to dwell in there. You can see that plastic is melting. So the friction from the wall of the tool is really not going to make things pleasant if you were to leave it in for long enough to weld. So I'm just going to cool that tool off. Stop it, and I'm going to inspect my work. The tool is going to be very, very warm still, despite the fact I just put some air on it, so don't just grab a hold of that. Everything looks like it's more or less going to plan. So what I can do blow away the debris. Now, if I'm careful, and I rotate 180 degrees in the x-axis, my y-axis position will stay true. So now all I have to do is bring my drill down into that hole that we drilled earlier. If you watch carefully, you can see it pulls it into alignment, and I just lock it. Now if I've done everything correctly, and if the plastic hasn't welded itself down in the bottom of the hole, when we get to bottom here, the slug should be released from the block and be held captive in the hole saw. So at this point, theoretically the block should be releasing, but I have a suspicion that some of that nice gooey plastic that you see stuck there has welded down in the bottom. So I've released the stop on the quill, so I can go a little further. There we go. Look at that. All that friction's causing it to melt. So what I'm going to do, cool that off. I'm going to pull my part out and inspect it, because I suspect that I've melted the plastic. It looks like I might be right. So we'll try the same thing from the other side. See how that just kind of pops into alignment nicely there? Oh. Makes our job nice and easy. See how that wiggles? That part, for all intents and purposes, has been cut out, but it just doesn't want to release. So, this is an excellent illustration of how friction and plastic can make a royal mess. So if I wanted to avoid this situation, I can slow down my RPMs and try that. That may not do the trick entirely because of the depth that we're cutting to. The other thing you can do is use a cooling fluid. It's very important that you check with the manufacturer's specifications for the type of plastic you're using, because of many of the cutting fluids, cutting oils, actually are not compatible with a variety of plastics. In some cases they say use clean water. So we could have kept this quite a bit cooler with some fluid, but because of the depth, it may not have fully solved our issue. But slowing down the RPMs and adding the water, that could have possibly been more or less the answer.